All right. So it says, consider a marble moving on a horizontal track with a speed of 10 meters per second. We're ignoring friction and air resistance. When the marble leaves the track and falls through the air to the ground, a vertical distance of 1.5 meters. Okay. So I'm not gonna really read the question. I'm just gonna go ahead and solve for what I can find. All right. So let's see here. Let's see what we got. All right. So there's a marble rolling off of a table. There's the marble. There's the table. It says the table is 1.5 meters in height. Okay. And the marble's initial velocity is in the horizontal direction, and it's 10 meters per second. Okay. And there's the path of the marble. And the marble's going to go this amount, that horizontal distance. This is the vertical displacement there. So on the left side, I'll write down everything I know about the horizontal motion. If I draw a velocity time graph, it's just going to look like this. 10. That's velocity in the x direction. And I don't know the time it's in the air, so I'm going to leave that alone for now. In the vertical direction, if I draw a velocity time graph, it's just like an object being dropped from rest. So it looks like this. And let's see here. If I draw an acceleration time graph, this is acceleration in the y direction versus time. We're just talking about the acceleration due to the Earth's gravity field. That means that we've got 10 times t as our change in velocity. And that means the height of this triangle here is 10 times t. Okay? And we know that this area is going to be 1.5 meters. So 10 t times t over 2, that's the area of that triangle, has to equal our 1.5 meters. Okay? That means that 5t squared has to equal 1.5 meters. And we divide both sides by 5. We get t squared is 1.5 divided by 5. Let's see what that is. Okay, 1.5 divided by 5. We get 0.3. Okay, that means that t, let's solve this over here. I'll move this down here. So that means the time that the projectile is in the air is going to be equal to the square root of 3. Square root of 0.3, I'm sorry. So that makes, let's see here, 0.3 square root, 0.55 seconds. So it's like half of a second that this thing is in the air, which totally makes sense. Okay? Then now that you know that this marble is in the air for about half of a second, we can put that here. So this is 0.55 seconds. This is meters per second. So horizontally, a marble should move horizontally a distance of 10 meters per second times 0.55 seconds, and we should get 5.5 meters. And so that's about it. That's everything I could think of that would be simple to solve for. Anyway, I hope that helps. If we change the mass of the marble, obviously nothing would change. And have a good day. Thank you for watching. All right, so I wanted to show you how to do a few of the problems if you are getting stuck. So I'm going to download the 2D problem solving worksheet. This is the one I like the most. I think it's the most interesting. So it should be downloaded, and I'll open it over here. And let's read the first one. It says that a boy throws a ball such that it hits his sister standing 20 meters away. The boy threw the ball at an angle of 35 degrees. Okay, let's see if I can try to remember all that. So I'll read it one more time. A boy throws the ball such that it hits his sister. That's too bad. That's not cool. And she's standing 20 meters away. The boy threw the ball at an angle of 35 degrees. Okay. Let's see here. So I'll sketch a simple diagram. Here's the boy. Here's the girl. Okay. And he throws the ball. So let's go back to the worksheet real quick. Boy throws the ball so it hits his sister standing 20 meters away. The boy threw the ball at an angle of 35 degrees. Okay. So I'm going to ignore any height. I'm going to say that the ball hits the girl at the same height this boy threw it, because I don't have any information about that anyway. So I would say that the ball goes something like this. It hits her at the same height that when he released it. That just makes it simpler. And again, I think that's what the problem is going for. So 20 meters is the distance they are apart. And this angle here is 35 degrees. Okay? And I think that's all I know. Let's double check that real quick. Boy throws the ball such that it hits his sister standing 20 meters away. The boy threw the ball at an angle of 35 degrees. Okay, well, I don't know much. Let's see what I can figure out. It's cool. So the initial velocity times the time. So I don't know either of those, initial velocity, nor do I know the time. My 1/2 at squared vector is going to be straight down. Okay, but I do know this horizontal vector here, my displacement. In this case, it is horizontal only, so I'm going to call it delta x. And this vector straight down is going to be 1/2 at squared. So half of a is 5, so this is 5t squared. And it seems like I should know something else to solve the problem. Oh yeah, this is 20 meters across here. So I'll go ahead and just label it as 20. All right. And let's see. Oh yeah, we also know that this here is 35 degrees. Okay. Well, I know one side and an angle, so I should be able to solve for everything. So let's try cosine. No, I'm going to use tangent. You'll see why in a moment. Tangent 35 degrees is going to be 5t squared over 20, right? That means that 5t squared has to equal 20 tangent 35 degrees. Okay, so let's just use a calculator now. Okay, so is it in degree mode? Yes. So 35 degrees tangent times 20 divided by 5. Divide by 5. So I'll double check that in a minute. But basically t squared is equal to this. And then t is going to be equal to the square root of all of that. Okay. So I'll do it again just to check. The answer should be 1.67, but let's check that. So 35 degrees tangent times 20 gives me this. Square root of that. Now I'm getting something different, so let me slow down and check it again. So 35 degrees tangent times 20 gives me that. Now if I take the square root, so it looks like t is 3.7 seconds. Okay, so that's the time for the projectile to actually hit the girl. And then I can now find my initial velocity. I can find, when I do that, okay? So now that I know t, this side here is going to be t squared times 5. So this distance here is about 70. That's meters. And then, so I should be able to find the other side. I could use Pythagorean theorem if I want. This side over here is going to be, let's see, if my t is 3.7, then this is going to be 3.7 times my initial velocity. So why don't I use sine to find my initial velocity? So let's do that over here. So sine of 35 degrees is going to be equal to 70 over 3.7 times V naught, right? So 3.7 V naught times sine 35 degrees is equal to 70. So let's divide both sides of the equation by 3.7 sine 35 degrees. I think I can do that. Yeah. So I'll divide the same thing here too, right there. I'm dividing by 3.7 sine 35 degrees. And it looks like, so V naught is going to be 70 over 3.7 sine 35 degrees. Let's see if I can calculate that. Okay. So I'm looking at okay, 35 sine times 3.7 equals 1 over x times 70, and I get roughly 33 meters per second. So this is going to be about 33 meters per second. And that's about it. I found the initial velocity that the boy throws the ball. I found the time that the ball was in the air, and pretty easy, not too hard. Anyway, I hope you like it, and thanks for watching. Have a good day.